Hi, and welcome to MSc. In this video, we're going to be looking at determining the vertex of a parabola using a method that's called partial factors. So when we're faced with a parabola that looks like this in standard form, not easily factorable, and not going to produce nice roots where we can use the method of factors, and we want to have a method that's different than completing the square, then there's a method that's called partial factors. And it uses the symmetry of a parabola, very much like the method of factors, but it does a bit of a workaround. I almost want to say like a bit of a cheat code to make things a little bit easier for us. So let me switch over to Desmos here for a second and take a look at the parabola. So I have it graphed here in blue, and you can see it's listed here. It's the blue graph. And that last value, that -5, it's causing this vertical shift and actually has a y-intercept of 5 here, -5. And so what would this look like if I could change that? So let's look at here. As soon as you enter a variable like this, Desmos allows you to add a slider. And let me graph this one. So there it is with c equals 1. You can see it has a y-intercept here, 1. And of course, if I make it -5, it should be the same as my graph above, which it is. What would it be if it was just 0? Well, those would be nice roots, wouldn't they? It would be 0 and some other number. It looks like maybe 3. And so that's what we have here. We have this equation. I can graph again and show you it's the same. You can see it switches from green to purple there. And so the method of partial factors actually redefines a whole new parabola that's been shifted up or down as necessary to remove the y-intercept and make it just 0. This makes our math a lot easier, but what you have to note about all these, and again, it doesn't matter which value of c I actually chose, we actually have a whole family of parabolas here that all have the same axis of symmetry. So notice no matter what I do to my c value, my axis of symmetry doesn't change. So while we are changing the parabola, and we're going to work with it a little bit, the axis of symmetry that it has is the same as our original one. That's the key piece that we're going to use to our benefit here. So let's go back to our example and try to work through this method of partial factors. So here we are back at the example. We can see our blue function here. Our blue function is our original function. That's our f at x function. And of course we have then an f and x axis that we've graphed this on. What we have here in purple is a new function. And it's the one that we shifted to remove or set rather, the y-intercept at 0. I'm going to call this new function n at x. And so we're going to redefine a whole new function called n at x. You can call it whatever you want. I'm calling it n for new. And it's going to be just 2x squared minus 6x. Again, it's removed that c value and forced it to have a y-intercept of 0. Again, to reiterate, like I mentioned before, the reason we're doing this is because we have an axis of symmetry now that is the same in both cases. So I have an axis of symmetry that moves through the vertex of both of these. And we're going to use this symmetry piece to our advantage. So what we do with this is we work with our new function for a moment. And what we do is we common factor what we can out of it. And so we say, okay, well, I can take a 2 and an x out of both of these. And this will leave me with x minus 3. And then we say, well, actually, we're going to let this equal 0 because we're actually looking for the intercepts. Right? And so this can be true when this is 0, 2x equals 0, which is true when x is 0, which shouldn't be surprising. On this method, you'll always have one of the intercepts here at the 0 point. And we'll also have this can be true when this is 0. Again, this is very similar to the method of factors. X is 3, and we can see it here. Okay, well, I now know how to calculate the axis of symmetry, right? That x equals h line. Well, I can do that because it's halfway between. And it doesn't matter it's a new parabola here, they both have the same axis of symmetry. So if I call this my x1 and this my x2, I can say my h value is x1 plus x2 divided by 2, which will be 0 plus 3 divided by 2, which will equal 3/2 or 1.5. You can work with fractions. If it's a non-repeating or non-terminating decimal, really, we should still work with the fraction because it's a precise value, it's an exact value. But here 1.5 is equivalent, we'll work with it. Now, what we did in the method of factors is we took this value and we subbed back into our function. We want to do the same thing here, but we want to be careful. I want to make sure that I sub back into this blue function, this f at x function. I'm looking for k, but I'm done with kind of my workaround. My modified parabola has served its purpose. It allowed me, with easy roots to find, allowed me to find the axis of symmetry. The other one would have not very nice roots and not factorable. So we have k is going to equal f at h. Not this new function, but the original one. And so this will be f at 1.5, or 3/2. And we're going to sub that back into this original function. So we'll get 2, and I will switch over to a fraction here, so you can see the fraction work that we'll do. And this will be 3/2. It's interesting how sometimes students are afraid to work with fractions. They'd rather work with decimals, but then sometimes with the fractions, things actually work out a little bit nicer, especially if you're trying to go without a calculator on some of these questions. So 3/2 squared will be 9/4. And this is 3 times 6, but I can reduce this first. So this will actually be 3 times 3, because the 6 divided by 2 is 3, minus 5. And I've run out of room, so I'm going to carry this on up over here. Notice we can reduce here. So 2 and 4, so I can make this 9/2 minus 9 minus 5. And this will be 9/2 minus 14, which would be 9/2 minus 28 over 2, which would equal negative 19 over 2. Okay, so our vertex here of our parabola that was not going to be factorable nicely for us is going to be 3/2 negative 19 over 2. Or we could write that out if we wanted with decimals, saying this is 1.5. If you wanted 3 significant figures, you could add a 0, and this would be negative 9.5. And again, if you wanted to 3 sig figs, you'd put the extra 0 there as well. So the method of partial factors uses the symmetry of a parabola, removing the y-intercept, or rather setting the y-intercept to 0. It doesn't remove it, it still has a y-intercept. Working with it, because it's so much easier to factor, find the axis of symmetry and then go back to the original function to find the vertex of it. And that's the method of partial factors. Hopefully you found this video helpful. If you have, please consider liking the video and subscribing to the channel. And as always, thank you very much for listening and watching.